All right, in this video, we're going to look at linear regression. It's a subject that has horrible formulas, but it's very useful in predictions. Let me start with an example. We have a record manufacturer thinks there is a correlation between money spent on ads and revenue from sales. So apparently he's looked at the data and he's seen like there's some sort of a connection. Here's where his data is. We have sales and advertising. And this table here, it lists if they spent 0.1 on advertising, and these are all in millions of dollars. So if they spent $0.1 million, they had sales of $2.4 million. If they increased their ad budget and doubled it, they would have sales of $4.5 million. If they increased to 0.3, $6.7 million. If they increased their ads to 0.4, they get $8.5 million in sales. And finally, if they spend $500,000, they get $12.3 million in sales. Obviously, one of the things they'd like to know is if we keep putting in more money into sales, will it keep paying off like it has been? First, what I would like to do is get a graph of the data. So I'm just going to draw a rough sketch of it just to get an idea of what it looks like. And in the x-axis, I'll put my 0.1, 0.2, 0.3, 0.4, 0.5. So we put X down there because that's the thing that the person wants to have control over. That's the control that they have, is how much money they can spend on their advertising. Unfortunately, they have no control over sales after they've done their advertising. So that's why the x-axis is referred to as the independent variable and the y-axis is referred to as the dependent variable. Let me go ahead and put these down. So my sales would be Y and my advertising would be X. And then I noticed it goes up to 12.3, so I think I'm going to go every 2, like so. So I have 2, 4, 6, 8, 10, and 12. And then let me get my points in. So if we look at the first point, where X is 0.1 and Y is 2.4, I'm going to try to estimate it on this graph. In the middle, between 2 and 4 would be 3, so I got to go a little bit less than halfway. So I'm just going to put a dot there. And then move on to the next piece of data here, which is 0.2 and 4.5. So if I put 0.2 in, I get 4.5 out. So let me see. 5 is halfway in between 4 and 6. It says halfway from there, so let me put a dot there. And then for 0.3, we got 6.7. So let me go ahead and draw it. 6.7 is a little bit less than 7, so I'll put a dot right about there. And then 0.4 and 8.5. So I'll go to 0.4 first, and then I'll go up to 8.5. And then finally, 0.5, 12.3. 3. That's a little above 12. So if you take a look at this, it's not quite, but it's almost a line. So the purpose of this section is to invent a line that goes through the data very nicely, and we'll use this line as our model of prediction. I'm not sure that was the best looking version of it. Let me see if I can make a better one here. I think if I come through something like this, yeah, maybe my line will be something like that. But you can see a lot of the data hugs the line fairly well. So we'll use this line will be our predictor. So the first thing we're going to do is see how well our data lines up. So we have something called the correlation coefficient. And it goes simply by the letter R. The correlation coefficient tells us how close the data is to a straight line. And here's the formula for it. They said none of these formulas are pleasant. They're all horrible looking. But I have to write them down so that we can make use of them. All of them, in case you're wondering, involve calculus in their derivations. So we know what all these things are by now. In the denominator is where it gets really bad. Here we have a square root n times the summation of x squared minus the summation of x, but that quantity is squared, and that's only half of it. Then we do the same thing with the y values. Like so. So let me go ahead and make a table with some extra things on them. So I'm going to put x and y. So for my x's, that's where the add costs were coming in. And then the y values, where were my y values? I had 2.4, 4.5, 6.7, 8.5, and 12.3. While we're here, we're going to want to get these things because they are involved in the formulas. So let me get the sum of the x values and the sum of the y values. The sum of the x values I can actually just do on the top of my head. I get 0.9, 1.2, 1.5. And the sum of the y's, I could probably do that too. Let me see, 6.9, 12.9, 13.6, 22.1, 34.4. Let me add some more columns. We're going to have to do things with them. If you notice, I'm going to need to do an xy, and I'm going to need to do an x squared. So let me do x times y, x squared, y squared. And that should take care of everything that we need. I'll underline them. Let's start with xy. This is really simple because this decimal, you just move it over 1. So x times y will be 0.24. And the next one will be 0.9. The one after that will be 2.01, 3.4, and 6.15. Let me show you something here. Stat, and go to Edit. Let me delete our data from there. I should have showed you this before, but I just didn't. Let me come over here. We can have our calculator do most of the stuff for us. Let me put in my x and y stuff. And then in L2, we're going to have 2.4, 4.5, 6.7, 8.5, Didn't like what I did there. 6.7. Let me hit, I must not have hit enter. 8.5 and 12.3. Now what you can do here is if you go and leave this screen, quit it, you can do stuff like this. I would like to take the contents of list 1 and multiply it, each of these items, by list 2. So check this out. What you can do is you can come up and go second L1, then times second L2, hit the store button, and then you can go second L3, and look. Let me go to my stats, back to edit, and now look, you have an L3. So let me check my numbers. They all appear to be right. Now let me quit this again. Now I want to do x squared, so that's like L1 squared. So what I can do is second L1 squared, and now I'll store that to L4 because I'm already using L1 through L3, so I'll put that into L4, enter. Let's go ahead, let me go ahead and do L2 squared and throw it into L5. So I'll do second L2 squared, store, second L5, enter. And now let's go back to stat, and let's go back to calc, not calc, I was where I wanted to be, edit, enter. You notice we've got an L3, an L4, and an L5. So I'm going to put those numbers in, since my calculator was kind enough to do those for me. So L4 is x squared, 1 4. So these I could have done those by myself. We have, I mean, without even a calculator, 0, 1, 0.04, 0.09, 0.16, and 0.25. And oh, I do want to get sums on these things. And then the y squared, let me get that. That was these numbers, so 5.76. You know what else too? I'm such an idiot sometimes. I could have just read it off from here. So let's see, we have for our y squareds, we have 5.76, 20.25, 44.89, 72.25, and then 151.29. And then I want to add that up too. All right, so I've got all those in there. Let me go ahead and let the calculator add up these columns. How does it do that? Well, if you go to, see above stats, there's something called lists. So if you go up to list, second stat, you want lists. Math, let me choose number 5. And then I'll pick second, L3, enter. And I get 12.7. And then L4 was the x squared column. So I'll do the same thing. I'll come back up here, enter, and then go back and overwrite this with an L4, enter. We get 0.55 there. And then finally I'll do the y squared column. So come back up here and overwrite the L4 with an L5. And we get 294.44. Now I have everything I need to use the formula. So let me keep it up top there. R will equal the n, in case you didn't know, the n is equal to 5. So we have 5 times, let's see, The sum of the xy's is right here, so that's 5 times 12.7 minus, now I need the sum of the x's, which is right here, is 1.5 times, I need the sum of the y's, that's 34.4. They make that look more like a multiplication dot. And then all of this is over the square root. In parentheses, I have 5 times the sum of the x squares, that's 0.55, minus, now I take the sum of x and square it, that's this guy here, so 1.5 squared. Finish that parenthesis and do the same thing for the y's. The sum of the y squareds is 294.44. And the sum of y is 34.4. And that one I need to square. And let me put that bar over all of that stuff. So let's go ahead and get that on the calculator and see what it tells us. Well, what I'm going to do, the way I'm going to draw it is I'm going to put the numerator in parentheses. So let me start a parenthesis, and I'll do 5 times 12.7 minus 1.5 times 34.4. Quick check on my screen to make sure that I've entered all of my numbers correctly. Yeah. Alright, so my numerator is in there and it's good. Now let's get the denominator. Let me finish that parenthesis. And then I divide. And then I start a square root. Now remember, this square root will grow as you build into it. So you'll notice I have a parenthesis times a parenthesis. So I'm going to start my first parenthesis. And that's this stuff right in here that I'm going to put. So I've got the 5 times the 0.55 minus 1.5, and then let me square that. Now it did not park me up there, it drops me back down, which is okay. I'll finish that parenthesis and start a new one. You don't need a multiplication sign, it's okay with that. I'll do 5, this is where I'm doing this part right now. 5 times 294.44 minus 34.4 squared, and then finish that parenthesis. And I think I've got everything. Let me go ahead and hit enter. I'll report this to about 2 decimal places. 0.99. This is considered a really good fit. It's practically a line. This 0.99, since it's close to 1, that just means our data lines up very nicely. Okay, we'll talk about the importance of R later, but right now we need it for our calculation. What this has told me at this point is that I may go and proceed with getting a linear regression line, because this number tells me that the fit is good. And so now we'll go through and get the linear regression line that will be used as a predictor for future data. So recall the slope intercept form of a line. So that looks like this. Y equals mx plus b. And that m you knew to be the slope. And that b, well, 0 comma b is the y-intercept. But both m and b have formulas. M looks like the following. We have n times the sum of xy minus the sum of x times the sum of y. Notice this is exactly the same as the other one, the same numerator as we had before. And then I have n times the sum of x squared minus the sum of x squared. So you only see x's in the denominator. That makes sense because when you think of slope, you think of rise over run. The rise part involves y's and the run part involves x's. So you can see we got y involvement in the numerator and we have only x's in the denominator. Let me put my numbers in. N, of course, was equal to 5. The sum of xy, let me just go and grab it again. Actually, look, I can copy exactly this because I told you it's exactly the same numerator. So 12.7 now I need the sum of x squared. I think that was 0.55. I can see it right there. This is the part that I want right here. Is just this parenthesis. And let's see. This time I'm going to let the numerator be encased in parentheses and the denominator as well. Guess if you hit delete, it'll go backwards like that. All right, that's useful to know. Now, I would like to have kept just that piece in the square root, but I'm sort of stuck because it's inside of the square root. I guess I could have squared it and did the square root, but I think that's just ridiculous. So let me go ahead and get my new numerator. 5 times 0.55 minus 1.5 times 1.5 squared. And then I can delete the 3 and the 4. Let me finish that parenthesis off. And let's see what happens when we hit enter. I get 23.8. And then move on to, for B, the y-intercept looks like this. It's the sum of the y's minus m times the sum of the x's divided by n. So our sum of y's, that was the 34.4. Our m we just did, 23.8. The sum of the x's was 1.5. And the denominator, the n in the denominator is a 5. Let me go ahead and have the calculator do these. Once again, I'll put the numerator in parentheses. So we have our 34.4 minus 23.8 times 1.5. Finish that, and then just divide by 5. And enter, and let's see what we get. Negative 0.26. So my regression line looks like this. Y equals 23.8x minus 0.26. Now, we'll use this line to estimate how much sales revenue he has if he were to spend $600,000. So if 0.6 million is spent on ads, what is the predicted sales? I should probably say, what are the predicted sales? So all we got to do then is take y equals 23.8 and simply put 0.6 where x was and have the calculator do this, and it will tell us this is what our estimate is. So I'm going to have my 23.8 times 0.6 minus 0.26. And let's hit enter. And I get 14.02. So to answer the question, what are the predicted sales? Well, the answer is about 14.02 million. So once you have the line, it's very easy to do predictions. Some cautions. The linear regression line is only reliable for data. Well, let's put it this way, for predictions that are close to the given data. By that I mean I tried x equals 0.6 and I got an answer and I go, well, that's probably something you can rely on. But if I go to 0.7 and plug it in, now I'm starting to stray away from what I think is reliable. This can't go on forever. It's only good for values that are close to the ones that you're given. So I might trust and use the predictions for 0.6 or 0.7, but beyond that, probably not. Now, something that I want to show you, let me go ahead and leave here, is I would like to show you the data and the line graphed together. And while I'm at it, I'm going to show you a piece of software that's freely available to you. In your URL bar, start typing GeoAlgebra. GeoGebra. What I call, actually I spelled that wrong. It's GeoGebra. So let me get rid of this. Oh, there it is. See it right there. GeoGebra. That's the guy I want. You can, I have it set somewhere, but I'm fine. We can start the calculator. That'll work. I want you to see what this thing's capable of because you might find it useful at some point in your life. First thing I'm going to do is put in my x and y values. So you can simply start a parenthesis, and then if you remember, I had 0.1 comma, the y value attached to that one was, where did that thing go? 2.4, and then hit enter. And then the other one, I'm going to do all 5 of them. Then I have 0.2 comma 4.5, enter. Then I have 0.3 comma 6.7, enter. 0.4 comma 8.5, enter. And the last piece of data, 0.5 comma 12.3. Got it. So right now it's kind of hard to see because it has a standard viewing size. In here somewhere in that button there, we can change the settings. And so what I'm going to do is my x minimum, I'm going to change that to 0. And my x max, remember it only went up to 0.5, so I'll just go to 1. That'll be more than enough. And then for my y min, I'll do 0 as well. And for my y max, it went up to 12.3, so I'll do 15 and see if the data is on there. So now let me leave here, and there it is. And it's kind of like I drew. It's fairly lined up. If you want to, there are things you can do in here. Like if I don't want those letters, I can right click in here somewhere, and then you can go to settings, and then you can choose to not show the label, and then when you leave here you can see that it doesn't have the label anymore. I don't care about that. I just wanted you to see a picture of these things all drawn out with the linear regression line also drawn. So we'll put y equals 23.8x minus 0.26. And we can see that that line really hugs the data well. Let me come back to settings. You know what's a good thing to do? It's always a good thing to give yourself a little cushion. I'm going to go negative 0.2 for the x's. And the y values, I'm going to start this, instead of 0, I'm going to go negative 2, like that. Because I would like to see the data here. I'm not exactly sure what those are doing there. Oh, it gives the root. There, I didn't want them. And one last thing I'm going to do before I leave here is I'm going to go to the settings, and I'm going to change the color of that thing to black. I think it looks better. It's easier to see. I'll leave the other data in there. Remember, that was letter E. I really don't care about those. Let me grab a picture of this. So there's my line. So this line here, that's y equals 23.8x minus 0.26. You can see negative 0.26 is just a little bit below the x-axis, and you can see that that makes sense. And the data hugs this very well. And then all we did when we did our prediction is I plugged in x equals 0.6, and whatever the y value was on that line was it. So if this point here was 0.6 and I think 14.02, that was the prediction. Now for the fun part. We're going to redo all of that stuff, but using the calculator. Before I do the calculator thing, though, I just want to show you one thing. How we know that the data is something that you can use predictions for is you typically will graph the data and see what kind of a shape it looks like it is, and then you'll use that as your model. For example, in the situation we just did, we had where the data lined up pretty nicely, even better than what I have here. And then if you draw a line going through this data here, you can see this R is close to 1. So the data models, or the line models the data very well. So this is very good, positive, linear correlation. So if it's close to 1, you know that you've got data that you can count on. On the other hand, you can also count on this data. If it happens to go downward, that is a negative slope like so, that's okay also. It still lines up. So if you draw a line through this thing, you can see that it still lines up pretty well. This R is close to negative 1. So this is a very good negative linear correlation. Now, as the data becomes worse looking, the R values will stray from either -1 and 1. In fact, no matter what, R is forced to be between -1 and 1 no matter what. -1 and 1 is perfect correlation. Anything less than that is getting close. But as R strays from -1 to 1, the data is more scattered. In fact, an R equals 0 scenario might look like this. The data may look so messed up that you might get the way the thing is calculated here, you may have R is close to 0, so no linear correlation. So what that means is if this guy was looking at his data and suppose his data looked like this, then he wouldn't bother even trying any of these methods because this doesn't do anything for him. He can't even come up with a plan in a situation like that. That's probably got to be the most difficult thing from a planning perspective, is something like that. Now, we're not going to cover it in this class, but you could have other things, like you could have something like this. And then you might have a curve that comes in like so. This might be exponential regression. Or you could have polynomial regression, or all sorts of possibilities. We are only going to look at linear regression because, well, it's hard enough for this class. What I want to do now is do the last example with the calculators. So I'll start with the TI-84 that I have first. And remember, Y1 is our X and Y. So our X was 0.1, 0.2, 0.3, 0.4, 0.5. And then we had 2.4, 4.5, 6.7, 8.5, and 12.3. I have already entered that data into the calculator. If you have, that's fine as well. Let me go to on. And let me check to make sure that I still have those in L1 and L2. Let me come back over. I don't care about L3, 4, or 5 in this particular exercise. Now, in order to get the information that I want, all you have to do is go back to Stat, go to Calc. Actually, what I wanted was number 4. And X list and Y list are in the correct spots. So let me enter my way through. And here they get it. For some reason, they use AX plus B instead of MX plus B, whatever. They tell you what the A is, and they tell you what the B is, and they also tell you what the R is. All that stuff is listed for you, and all you had to do was enter the first 2 columns. You don't have to enter all that other stuff. In fact, they could have been cleared out of there. Which reminds me, if you wanted to clear out anything, click on Stat and look at number 4. I would like to get rid of L3, L4, and L5 all at the same time. So I'm going to put L3 and then a comma, and then I'll put an L4, another comma, and then L5, enter. And then when you go back to your stats and edit them, you'll see that L3 through L5 are gone. And now I can do the same thing. I could calculate number 4. Just enter my way through. And you see I did not require the information. So you see I got my 0.99 from my R. That meant it was very good. My A is the slope, the 23.8. And the B is negative 0.26. Now, one thing that you're going to want to do, if you go about trying to graph something in the future, you're going to get an error because your stat plot is turned on. So you got to go up to second, stat plot, and you want to make sure that it's off. So make sure that all your plots are off. That way they won't interfere with things in the future. Now that we've got the TI-84 done, I want to move on to my other calculator, which is a lot harder to use, and that's the TI 30X IIS. All right, first thing, remember to enter stats. So to go second, data, and choose to variable by moving over, hitting equals. Now we'll start entering our data. So press data and put in the first piece for x, that was 0.1, down arrow, put in 2.4 for y1, down arrow, now put in 0.2 for x2. The next y value I believe was 4.5. Go down, next x value is 0.3. The next y value is 6.7. Down arrow. Then we had 0.4 for x. That was an 8.5. And then we had 0.5 and we had 12.3. And after you got that, I like to hit enter down there at the bottom, just sort of finish it off. Now, if you want to see what all the things are that we did, hit stat var, and you get a whole bunch of stuff. So you've got your n was 5. They give you the mean of x. They give you the sample standard deviation of the x's. But if you keep going, then they repeat all of those things for the y's. And then you've got the sum of the x's, the sum of the x squares, the sum of the y's, the sum of the y squares. Now we're getting to it. A, there was our slope. B, there was our intercept. R, there was our R. So it's extremely easy to do this so long as you're just using the calculator. You saw those formulas are nasty. I'm not going to require you to memorize any of those formulas. Just be able to use your calculator. All right, for my next example, I wanted one where the y values went down. Now look at the things that are, this is out of the textbook. The correlation coefficient R and the equation of the regression line. And then we'd like to predict the next value. So our next x value that we would use would be 50 out here. So that is the next one on the list. Let me write it 50. So they're looking to figure out what that next block is supposed to be. Well, let's put this data into the calculator. The only calculator that comes up on my screen is the TI-84, so I'll do that. Your other kind of calculator, go ahead and use it. Hopefully you'll be able to follow along using your own calculator. So I'm going to go to Edit. And it looks like I have 5 pieces of data, so I'm going to just overwrite. And then I'll do the same thing over here. We have 100, 86, 70, 66. Be careful there. 66, 48. And remember, all we have to do is click on Stat and go to Calc, choose number 4. I've got everything I want there. There's my R. Notice that the R is negative now because the numbers, the Y values are going down. So negative 0.99, or I'll say 0.988. So R. You know, I don't know why I don't do it. I can just grab it all right here. Everything I need is listed right there. I've got my R. And I've got my y equals mx plus b. That's negative 1.24x plus 98.8. Now the next thing, what they want to do is predict it for the next x value. So predict for x equals 50. Well, that will look like this. Y equals negative 1.24 times 50 plus 98.8. Let's let my calculator do that one. So we have negative, oh, I didn't mean to do that. Let's clear out of there. Negative 1.24x too much use of the keyboard will cause that. Plus, actually, let me change that x to times 50 plus 98.8. And I get 36.8 will be my next one. I'm guessing, does it say to round? No. It looks like it should be 37 probably, but it's in line with generally the trend going downward. The R being 0.988 is very good. That means the data lines up very well. And now let's plot the data in the regression line on the same graph. So once again, I'm going to do that with the calculator. You cannot do this with a non-graphing calculator. So I'm going to put in here, I'm going to put the negative 1.24x plus 98.8. Now I also want to turn my stat plot on. So let me hit enter here. And it's got L1 and L2, which is exactly what I want. You could use dots, a plus, or that little block thing, but I'm going to stick to what I have right there, which are the a scatter plot, just the points. Now you also want to set up your window. Now if you look at this, I don't know what that's doing, but if you look at this, the x values go from 0 to 40 or 50 if you want to go that far, and the y values go from 100 down to 48. So what I'll do is I'm going to let me go to my window. I'm going to let x min be -10, but I'm going to let x max be 60. So it'll cover the data without a problem. And then for the y values, I've got a min, I don't know, let's do 0. And then the max, we can do like 120 or something, so long as it covers the data. And let me see what a graph looks like from all this, see if I did it right. So there's actually 5 pieces of data. When x was 0, y was 100. But there you go. Let me go ahead and grab a picture of that. Now, if you're given something like this on an exam, most likely we're also going to want you to tell us what these points are, and I don't have that on here. However, if you come back to the calculator and you hit the trace button, I must have been seconded. Let me come back to the graph. I must have had the second button pushed. I went trace, and now look what it does. It tells you what they are. X is 0, y is 100 there, but if I hit the right arrow, it'll take me to the next one. X is 10, y is 86. There is 0, 100, and then the next one is 10, 86. Let's see what the next one is after that. Then I have 2070. And let me keep going to get the last two. I get 3066. And then finally, for the last one, we have, let me continue. We have 4048. And then we even did one more when x was 50. Remember, the prediction itself is actually on the line. So 36.8, if we come down here and space it out just the same amount as before, like so, this one here then, the x value would be 50 and the y value would be 36.8. It's important that you know that the predicted value is actually on the line itself.